Before we mine data, we need to get the data ready. Getting data ready involves pre-processing of data. And before pre-processing of data, we need to have a very closer look at our data. This involves having a closer look at attribute and data values. Real-world data are typically noisy, enormous in volume, often in several terabytes or more. This lecture is all about getting familiar with data. In earlier lecture, we covered introduction to data mining. We discussed what is data mining, what are the process blocks of data mining, Walmart's case study, and a course outline, which involved something as course contents, credit and examination scheme, course objectives, outcomes, and the learning resources to be referred. In this lecture, we shall be learning a very simple and basic terms which are to be known with respect to the further topics to be learned: data object, data attributes, and types of attributes. Knowledge about data is useful for data pre-processing. We want to know what are the types of attributes or fields that make up our data and what kind of values are assigned to each attribute. Which of the attributes are discrete, which of the attributes are continuous valued, and so on. So let us learn these basic data primitives. We learned what is data, what is knowledge, information, and all in the first lecture. Data are nothing but the recorded facts. They are also referred as measurements or observations. Measurements or observations are stored as collection of data objects. And data object is nothing but set of values for variables. What is variable? Variables is something which can be measured. So we say that measurement is process of applying values to the attributes. Examples of data is nothing but a vehicle data, weather forecast information, geographical information, genetical data, healthcare data, and so on. Look at this table. This table has some rows and some columns. In columns, we have something like permanent registration number, name, gender, CET score, branch of a student, year he is studying, email ID, and mobile number. The rows represent the observation, measurement, a data object. So 123 permanent registration number with a name Meeli Nair, a female with CT score of 88 studying in first year of mechanical engineering, is one data object with email ID and mobile number. The Milin Thomre is the record, a data object with PRN number 835, male, and so on. In this table, we have some rows and we have some columns. The rows are nothing but the data objects. So, group of data objects form a data set. Data object represents an entity. One entity for one student information in the earlier table we just studied. In database of students, object is a student. In sales database, object could be customer, store item, sales. In medical database, patient, doctor, supporting staff represent data objects. In university database, student, professor, the courses, the programs form a data object. Data objects are typically described with attributes, and attributes are of various types. Data objects are referred with variable names, samples, examples, instances, data points, observations. These are the typically terminology used in statistics. If we refer to database management system, then we were referring them as data tuples as well as records. The rows in database, as in earlier table, they represent objects, and the columns are referred in terms of database management system fields. The next simple data primitive which we need to learn is data attribute. What is a data attribute? An attribute is a data field representing characteristics or feature of data object. They are also named as variables, fields, characteristics, dimensions, or features. The term dimension is commonly used in data warehousing. Machine learning literature refers it as feature. Statisticians refer it as variable. Data mining and database professionals refer it as attribute. If you look at this table, then the rows are representing data objects and the columns are representing data attributes. Attributes or data, you can say, the values which are stored for each variable, for each attribute, are also referred as scales of measurement, and they are categorized as nominal, ordinal, interval, and ratio. A term coined very popularly is NOIR. It is very easy for you also to remember this term NOIR, which is nothing but representing the four types of attributes: nominal, ordinal, interval, and ratio. Attributes can be discrete or continuous. Attributes are also categorized as either qualitative or quantitative. Let's learn these four kinds of attributes. Let us learn about what is discrete, continuous, qualitative, and quantitative. This diagram indicates the same categorization of data. It is either qualitative or quantitative. In qualitative, we have nominal, ordinal. Nominal data is also categorized as binary. Binary data is either symmetric or asymmetric. Quantitative is a numeric data which could be either discrete or continuous, and numeric data is either interval scale or ratio scale. We shall be learning each one of these in brief. Qualitative attributes. Nominal data attribute is a qualitative data attribute. The name nominal comes from the Latin word nomen, which means name. Nominal data items are differentiated by simple naming system called as relating to the names. Values of nominal attributes are symbols or names of things. Hair color could be one of the attribute, and the hair color could be either gray, white, black, brown, blonde, golden, and so on. And it represents a nominal attribute. The other examples could be gender, which could be male, female, types of pets, religion, etc. Each value represents some kind of category, code, or state. Nominal attributes are also referred as categorical because they categorize the data into set of nominal attributes are also referred as categorical. If we take an example of gender as an attribute, then whole class can be divided into two categories, one male and the other female. These values do not form any meaningful order. If we have hair color as black, brown, golden, grey and so on, they do not form any meaningful order. You can write them in any order. If we take an example of person as an object with hair color as one of the attributes and the possible values as black, brown, blonde, red, grey, white and so on. If we consider an occupation of a person, it could be teacher, dentist, programmer, farmer, design engineer and so on. If we take a designation for the teachers, then it could be professor, associate professor, assistant professor and similar. In this, it is possible to represent these names by some symbols or numbers. For example, we can have 0 representing black color, 1 representing brown and so on. These numbers do not have any real meaning. They are assigned simply for differentiating the objects. If we look at the players in cricket, every player is given some number. That number is just differentiating the two players. It do not actually form any meaningful order. Nominal attribute values do not have any meaningful order. They are not quantitative, they are qualitative. So it doesn't make any sense in computing their mean or median. We shall be learning data preprocessing in the forthcoming lecture, where we'll compute mean and median of these attributes. When they are nominal, they are like simply names, so that it makes no sense in computing their mean or middle because they are qualitative. However, we can compute a mode which represents a most frequent object. So in brief, nominal objects, it is one of the data attributes. Among the NOIR, nominal is the lowest level of measurement. It can help in classifying a data like it is shown in the pie chart. You can have say that 50% of people have black color, 30% have golden color, 20% have brown color, and so on. Order is arbitrary. It do not make any sense of ordering them. They are in mutually exclusive categories. When one person's hair color is black, it is not it is not a color from the remaining categories, like it is not golden, it is not brown, it is not white, and so on. When you say that one student, among set of students, the gender for particular person is male, it is obviously not the female. So they are mutually exclusive categories. These nominal data have a limited descriptive ability because they simply name the data. Binary data attributes is one of the nominal attribute with just two categories like 0 and 1. Typically, 0 means the attribute is absent and 1 means the attribute is present. If we take an example of, say, medical test, say for corona, COVID-19, then the test could be positive or negative. So if it is positive, obviously it is not negative. So we said that it is mutually exclusive. You can represent this positive and negative with the numbers 0 and 1. So binary attributes are also referred as Boolean because they are in one of the two states, either true or false. These binary attributes are further classified as symmetric and asymmetric. Now, what is symmetric? Both the values are equally important. For particular person information, say student information, when you have an attribute gender and when you give a value male, then it is equally important for giving a value for some other record as female. Because set of students who are categorized into male students and the other in the female, both are equally important. We just can't say that one category, one value is important and the other is not. So we say that this particular binary nominal attribute is symmetric. Asymmetric is both are not equally important. If it is a medical test, then when we say that among 10, 2 patients report is positive, then we concentrate only on those who are positive patients, and we start with the further medication for that. So we give more importance to only a positive patients. So it is said that it is asymmetric. This is a table representing the same discussion which we just had. The next type of attribute is ordinal attribute. In the ordinal attribute, it is like a nominal attribute with the additional feature that the order makes a sense. The ordinal, ORD stands for order, an attribute with possible values having a meaningful order. The values can be ranked. When we say that some attribute, let's say a class rank, then the first rank holder, the second rank holder, the third rank holder, when we say that Mr. X is first rank holder, Mr. Y has second rank, Mr. Z is third rank holder. If it is a race, then who came first, who came second, who came third, the order matters. So ordinal attribute is like a nominal attribute, but the order is meaningful. These values can be ranked with the magnitude, but values between the two successive values is not known, may not be known, may not be equal. The example is, let's say we are trying to find out the satisfaction level of customers. The customers are supposed to rank supposed to say whether it was excellent, the product was excellent, satisfactory or poor. Here the order has a meaning. We are going to rank the items with respect to excellent level of satisfaction, then satisfactory, and then poor. So order has a meaning, whereas we cannot meaningfully talk about the values between the two. Like we cannot talk about what lies between excellent and satisfactory, what lies between satisfactory and poor. There is no meaning in discussing this. So it is said that nominal attributes have a meaningful order, but the values between the two uh, value between lying between the two has no meaning, or it is not known, or we can say that it is not equal. Ordinal attributes are useful for registering subjective assessment of qualities that can be measured objectively. We have categorized our attributes as qualitative and quantitative. When we say that some particular student has scored double of the marks than some other students, say A, when we can quantitatively measure the items, they are numeric data items, and when we say that they are qualitative, they are either nominal or ordinal data items. And ordinal are generally used for surveys, conducting something, saying customer satisfaction for excellent, very good, satisfactory, and poor. Another important thing is, like nominal, we can assign some values, numbers to these names. We can have 0 representing excellent, 1 representing very good, 2 representing satisfactory, and 3 representing poor, and so on. Nominal, binary, and ordinal attributes are qualitative. They describe feature of an object without giving an actual size or a quantity. When we say that customer satisfaction has rated it to excellent, we are not assigning any size nor we are assigning any quantity to it. But when we measure something, say weight of a person, height of a person, we are assigning some quantity to it. Those are quantitative measures. In ordinal and nominal, we do not actually assign a quantity, we give some name to it. The values which are qualitative attributes are typically words representing categories. Integers can be used for representing them with the numbers. Ordinal data is considered to be categorical. Like nominal, we can have it, this is also categorical. Difference between nominal and ordinal is a natural order exists for ordinal, whereas it do not exist for nominal. Values for ordinal simply express an ordinal order, but they do not have any value assigned to it. These were qualitative attributes. Let us learn about quantitative attributes. Among that nominal and ordinal we learned, the third data type is numeric data type. We are referring it as numeric attribute because the values are stored for the attributes. Numeric attribute is quantitative and it is measurable quantity. It is represented using either integer or real value. Numeric attributes are further classified as interval scaled or ratio scaled. Interval scaled are ordered like ordinal, and interval between the values is known and is equal. Whereas in case of ratio scaled attributes, they are ordered having interval values, but it has inherent zero in it. What is this? Let us learn. For interval scaled attribute, the values have order and can be either positive, negative, or zero. They can be ranked, can be compared, can quantify the difference between values. Temperature attribute is one of the most popularly posed example for interval scaled attribute. Another examples are marks, percentage of marks, grade, or a similar are the interval scaled attributes. When we note down temperature after say 1 hour, then the temperature could be either negative, 0 or positive. When we say that the temperature measured at particular hour was say 15 degrees Celsius, and say another hour, after 1 hour it became 30 degrees Celsius. So we can say that there is a difference of 15 degrees Celsius for the previous hour and the current hour. Within 1 hour, we can say that there is a temperature rise of 15 degrees Celsius. But we cannot really say something as at the temperature 30, it was double of the hot as compared to when temperature was 15. So we say that in interval scaled attribute, we can talk about the difference. We can compute mean, median and mode as a central tendency, but we cannot talk in terms of ratio. So they are said to be interval scaled attributes. In ratio scaled attribute, it is also a numeric attribute, but it has an inherent 0 point. In case of interval scaled, we had a 0, but it had a meaning that the temperature at particular point was 0. That is, if measurement is ratio scaled, we can speak of value as being multiple of the other value. In case of temperature, we could not say that temperature is double hotter. It is double hot than at 30 as it was at 15. Whereas in ratio scaled, we can talk about multiple or a ratio of another value. These values are also ordered and we can compute the difference as well as a ratio. We can compute central tendency in terms of mean, median and mode. In next slides, we will be having one table where we can have a comparison of all the 4 attributes in one table. It will be very clear there the difference between ratio scaled and interval scaled. So examples of ratio scaled attributes are years of experience, total number of credit earned and similar. The attributes can be further classified as either discrete attributes or continuous attributes. Discrete attributes has finite or countably infinite set of values which may or may not be represented as integer. The attribute hair color, medical taste, year of engineering are the discrete attributes. Discrete attributes may have numeric values such as 0 and 1 if they are binary. If it is an age as an attribute, the values may range from 0 to 110. The attribute can be countably infinite. In discrete mathematics, you have learnt about what is countably infinite set and what is uncountably infinite set. Any set, if you can have one-to-one mapping between the set of natural numbers and a given set, then we say that it is a countably infinite set. Example of attribute as customer ID, it is countably infinite. Number of customers can grow to infinity, but in reality, the actual set of values is countable, where the values we can be put into as one-to-one correspondence with set of integers. If an attribute is not discrete, then it is said to be continuous. The term numeric attribute and continuous attribute are often used interchangeably in literature. This may be confusing because in a classic sense, continuous values are real values, whereas numeric values are integers or real values. In practice, real values are represented using finite number of digits. Continuous attributes are typically represented using floating. Let us have a look at this table where there are 4 columns and 3 rows. We have taken some examples to understand the difference between the 4 attributes well. First example of attribute is color, and color could be blue, red and yellow. Here we have given some numbers to it as 1, 2 and 3. We could have given blue as 2, red as 1 and yellow as 3 again. Here order doesn't matter. Another example, say there was some race conducted and the ranks. First rank holder, second rank holder and third rank holder. So order matters. Say first rank holder, if it was a running race, completed the race in 1 minute and 22 seconds. Second one finished in 1 minute and 56 seconds. Third in 2 minutes and 13 seconds. If you look at the difference between, they are not equal. Difference is not equal. Rather, there is no point in calculating the difference. This difference is not actually measurable, because we are talking, once the race is over, we are talking about who's the first rank holder, who's the second, who's the first winner, who's second winner, and who's the third winner. Let us look at one more example, a temperature. At 1 p.m. we noted the temperature as 30°F, 2 p.m. 60°F, and so on up to 5, and at 5 a.m. it was minus 20°F. Again, the order matters, because we are noting down at some particular interval which is to be counted. The difference can be calculated. There is a difference of 30°F between 1 p.m. and 2 p.m. We can say that there is a rise of 30 degree from 1 p.m. to 2 p.m. There can be 0° temperature noted, there can be minus temperature noted. So 0 is not a true start point. 0 has a value, 0 has a meaning that the temperature at 4 a.m. was 0°C. We cannot actually talk about the ratio. As I said earlier, we just cannot say that at 2 p.m. it was double hotter than at 1 p.m. So we can, these are, for temperature, the order matters. Difference can be calculated. Need not be a equal interval. The values cannot be, the note, when you note down, can be at equal interval, may not be. 0 is not a start point, a true start point. 0 could be one of the observations. Ratios cannot be calculated, whereas we can talk about differences. Let us look at one more example. Test marks for, let's say, first month for data mining and data warehousing. The scores of the students for test mark are as 0, 30, 55, 60, 80 and 90. Here also, when we sort them in increasing order or in decreasing order, say 90, then 80, 60, 55, 30 and 0, the order matters. Difference can be calculated. There is a true 0 point. Assumption here is there is no negative marking. So there is a 0 start point and ratio can be calculated. We can say that some particular students has scored double of the marks as compared to some particular student who scored 30. For 60 marks, we can say the marks are double of what the person who scored 30. When we say that some student has scored marks 0, we do not actually mean that the person do not have a knowledge of that particular subject, but the marks he has scored is 0. The other example is survey of a colors. Say among 10 people, 5 like blue, 3 like red and 2 like yellow. We can say that 50% like blue, 30% like red, 20% like yellow, but we cannot still have an order among them. Difference between these race winners need not be same. Another example of this, first one is nominal, second one is ordinal. In ordinal, when we conduct surveys, then excellent, average and poor, the order matters. We cannot calculate, actually talk about difference between the two and so on. In case of temperature, we can say that temperature raised from 30 as I discussed earlier. And when the temperature is 0, does not indicate a 0 value, rather it indicates that the temperature was 0 at particular time. This table gives you nominal, ordinal, interval scaled and ratio scaled at a glance, and you can easily note a difference between these 4 types. If you look at this diagram, you can see that who is subset of other. So from lowest level to upper, nominal to ratio, Nominal is subset, and the outer, that is universe, for which includes all the values, is ratio scaled. This is one more table which is again giving you an idea of all four types and a comparison. For nominal, the examples are given, then what could be a measure of central tendency is written, and the characteristics for all the four categories is written. We just discussed with the earlier examples, and one more example which is quoted at bottom is a cricket players. For cricket players, when you give a number on their uniforms, it is just to differentiate between two players. It do not form any order. When it forms order, then it is, if the order of players who will come for play, then it is meaningful order, then it becomes ordinal. When you can compute a difference between, like a scores of runs made by each player, then it becomes an interval scaled. And when you actually talk about the ratios, then it becomes a ratio scaled. This is again another simple table which is giving you the same comparison with respect to a meaningful order who can have. So nominal do not have meaningful order, whereas ordinal, interval and scaled attribute has a meaningful order. If we talk about measurable difference, then nominal and ordinal, there is no sense in having talking about their difference, whereas in case of interval and ratio scaled, we can talk about the measurable difference. About ratio scaled, again we cannot talk about the ratio for first three, that is nominal, ordinal and interval, whereas we can talk about the ratio, measurable ratio, in ratio scaled attribute. For ratio scaled attribute, there is a true zero. For remaining, there is no true zero. So let us summarize what we learnt. Data object represents an entity. An attribute is a data field representing characteristic or feature of a object. Type of an attribute is determined by set of possible values that attribute can have, and they are categorized as nominal, ordinal, and interval scaled and ratio scaled. Can be also listed as nominal, binary, ordinal, or numeric. Attributes can be either discrete or continuous. Discrete attributes has finite or countably infinite set of values. When attribute is not discrete, it is said to be continuous. These are some simple home assignments which you are supposed to solve and submit. In next lecture, we shall learn about statistical description of data. Before we pre-process data, we need to learn few more terms with respect to statistics, which I have named as basic statistical description of data, which includes study of computation of mean, median, mode, variance, standard deviation, and covariance. Hopefully you understood the topics which we learned today. vhp2020.mcerc@gmail.com is my email ID. Submit all the assignments given for today's lecture and post your feedback and queries at this email ID. You can visit site www.mcoerc.org for next lecture. Browsing through this site, you will also able to see the various courses for which the video lectures are offered. Thank you.